5.5, applications of synthetic division. Applications of synthetic division. Okay, so first, though, before you can do applications of synthetic division, we kind of need to know what synthetic division is, right? So those of you that were gone on Friday, and because that video didn't upload, I just want to work a couple of your homework problems with you, okay? So synthetic division is a shortcut. It makes long division faster, okay? So this is number 14 from your 5.4 part 2 homework. Okay, I'm just going to work some problems with you. That's pretty much all we did Friday anyway. We worked problems. So number 14, it says we want to take the polynomial 3x cubed minus 2x squared plus x minus 4, and we want to divide that polynomial by x plus 3. And our long division method for that had us put like 3x cubed minus 2x squared plus x minus 4. And then we put x plus 3 out here, and we went with it, right? Do y'all remember doing this for homework? Okay. So this is better than that. The reason that I said synthetic division most of the time works is it works best if this number in front of x is 1. If it's not, on the divisor, the coefficient of the divisor, if that number's not 1, there is a way to manipulate your function to where you could still use synthetic division, but I think that's overuse. I think it's much easier to just go straight into long division instead. Do you see what I'm saying? Okay, so this is a shortcut. It works the best when that number is 1. If that's the case, you take your divisor, okay, this is the thing that we're trying to divide by, and you set it equal to 0. And you solve for x. We need it to say x equals before we can work with that number. Then we put that number, -3, in a little box. You see how I set it equal to 0 and solve for x? Now, what comes next is I need the coefficients of each term represented here. So I started with a degree x cubed. Highest degree is 3. So I need the coefficient of x cubed and x squared and x and the constant. Every single term was represented here. One thing that we talked about on Friday is if for some reason there is no x term or there is no x squared term and there just happened to be nothing there, you would have to put a 0 in the place to hold that spot. Okay, so if a term is not represented, so we started with 3, we need something for 3 and 2 and 1 and the constant. If there doesn't exist a coefficient for every single term, then you just put a 0 in the placeholder. Is that making sense? That happens a couple of times in your homework. But that's not the case here. Here we have the x, so we have the 1. Okay. Our first step when synthetic division is to drop down the number in the first column. Drop it straight down to the bottom row. Now we're going to multiply 3 times -3. What do you get? -9. We write the -9 under the next column, under the number in the next column. So right under that -2. And then we're going to add down. So we're going to multiply up, add down. Multiply up, add down. So we're adding -2 plus -9. What do you got? -11. So again, we're going to multiply up to here. -11 times -3. 33. We're going to add 1 plus 33. 34. We'll multiply again. 34 times -3. -102. Good. And we're going to add -4 plus -102. What you got? -106. Okay. So our answer without all of these arrows in the way, our answer is going to come right here. This 3 minus 11 plus 34. This is the quotient, or it's the coefficients for the quotient. Because we divided by x, and we started with x cubed, if I take x cubed and I divide by x, what's left? X squared. So this 3 goes on an x squared term. We drop down a degree from what we started with after we've divided. Remember, this synthetic division is still division. So we're dividing by x, we get down to x squared. Are y'all good with that? Minus 11 what? X, good, plus 34, with a remainder of negative 106. There's several different ways we could write that. You could write it just r minus 106, or a remainder of negative 106. I really prefer to look at it with my divisor, x plus 3 times my quotient plus 34 with a minus 106 on the end. So I can tell, hey, if I were to go through and FOIL this out or distribute this out, I could get back to what I started with. This is my favorite. It makes the most sense to me. What do you think? Okay? The synthetic division is not bad. It's pretty quick. Let's look at a couple more homework problems. I know that you had number 64. This is from your homework as well. 64, they give you the length of a rectangle is x plus 5. The length of the rectangle is x plus 5. And the area of that same rectangle is 2x squared plus 9x minus 5. And the question is, find the width. Find the width. Okay, so how do area and length and width relate on a rectangle? Okay, area is equal to length times width. So if I wanted to get my width by itself, what can I do? Divide by the length in both places. So we're going to take our area function, this 2x squared minus 9x, or plus 9x minus 5, and we're going to divide it by this length binomial, x plus 5. Are you all understanding how this is working? So what goes in the box? Negative 5 in the box. You set that x plus 5 equal to 0. Solve for x. Negative 5 goes in the box. What's the first coefficient that I'm going to write down right here? 2. And then, okay. I don't need a 0 because I've got everything represented. I started with x squared. There is an x term. There is a constant. Then we're going to drop the 2 straight down. 2 times negative 5. 9 minus 10. Negative 1 times negative 5. Negative 5 plus 5. 0. Okay, this is cool, and this is kind of where we're headed today. The remainder in this problem is 0. What that tells me is that x plus 5 was a factor. That was the length. And the other factor that I just found here, 2x minus 1, is the width. 2x minus 1. And there is no remainder. We just found the two factors of the area. Okay, so the answer here would be 2x minus 1. How could we check it? Multiply by the length, and you should get back to the area. Are we understanding? Yeah? Okay. Number 70 on your homework. just really quickly, 70 gives you volume, it gives you length, it gives you width, and it asks for height. Volume is 10x cubed plus 30x squared minus 8x minus 24. Length is 2. Width is x plus 3. Height is the unknown, h. And so you have this situation where volume equals length times width times height, and you're supposed to solve for height. But it's kind of scary as to what do I do? How do I use the synthetic division here? What do I do to get the width where I can divide by x plus 3? And so you're going to divide off the length first. So you'll take your volume, this 10x cubed plus 30x squared, all of that stuff, and just divide it by 2. Divide everything there by 2. And then you'll be ready to go with the synthetic division. Do you see what I'm saying? So you'll be left with 5x cubed plus 15x squared minus 4x minus 12. And you're going to divide that by your x plus 3. Okay. I don't want to work that one all the way with you, but I thought I could get you started on it. Okay, so that brings you up to speed on what is synthetic division. Okay, it's a shortcut. It's a really fast little choop, choop, choop method, and you can just multiply and add, and all of a sudden you've got an answer, right? So today's lesson talks about, well, what do I do with that? Why is that useful? Okay, so the first thing we're going to talk about is called the remainder theorem. And I need you to write down what this says in the top. If a polynomial f of x is divided by x minus k, then the remainder is the value f of k. Do I need to blow that up for y'all back there? If a polynomial f of x is divided by x minus k, then the remainder is the value f of k. All right, so if a polynomial f of x is divided by x minus k, then the remainder is the value f of k. Okay? So here's what we're going to do. This is example 1. It says, use the remainder theorem to evaluate f of x equals 6x to the 4th minus x cubed minus 15x squared plus 2x minus 7. Write this polynomial down. This is example 1. We are going to evaluate this polynomial at x equals 2. Evaluate this polynomial at x equals 2. So what's one method that you learned to do that? Plug it in, right? We can take 2 and we're going to put it where x is. 6 times 2 to the 4th minus 2 cubed minus 15 times 2 squared plus 2 by 2 minus 7. That's what it means. Find f of 2. Evaluate. Okay. But sometimes I find myself without a calculator. Sometimes I find myself in a position where I don't know 2 to the 4th off the top of my head, which, by the way, is 16. But then I got to multiply 16 by 6. And you can see how this gets out of hand pretty quickly if I don't have a calculator sitting in front of me, right? So the other option is to use synthetic division. The remainder theorem says that our remainder from our synthetic division is f of 2. Are you ready to try it? So what goes in the box? Well, here this is already set up as x equals. It's not x minus 2 where we'd have to set it equal to 0 and solve to figure out what's in the box. Do you see the difference? On the other problems, it was given to me as a linear factor, x plus 2. Here, it's given to me as x equals 2. So I just put the 2 in the box. No changing signs. Everybody hear me, because that'll mess up your homework if you didn't catch that. If it's already set up as x equals, that number just goes in the box. If it's not x equals and it looks like a factor, you got to solve for it. Okay. Coefficients here, 6, -1, -15, 2, and -7. Does everybody have an accounted for term? Everybody has a place here. No zeros. Okay. Now we drop the 6. 6 by 2. -1. 11 by 2. -15. 7. 7 by 2. 14 plus 2. 2 by 16. 32 minus 7. 25. Anybody got a calculator on them? Anybody that's fast that can plug in a 2 to this function and check it for us? Oh, wow. Rock, paper, scissors. Somebody get up and go get a calculator. I'm not making eye contact. Y'all hurry. 25. F of 2 is 25. Do you see how the synthetic division is helpful here? I mean, you could plug in, but what if my number's not nice like 2? And what if my exponents aren't so low as 4? What if all of a sudden I'm dealing with like 3 to the 7th? Yuck. Synthetic division is pretty quick. Okay. Do you want to try it to go with this one? Do you have, yeah? You want to try it? Okay. So this will be try it number 1. Try it number 1. And it says evaluate f of x equals 2x to the 5th minus 3x to the 4th minus 9x cubed plus 8x squared plus 2 at x equals -3. I'll race you. 2x to the 5th minus 3x to the 4th minus 9x cubed plus 8x squared plus 2. And so what are they asking me to do? They're asking me to find f of -3. And we could plug in the -3, or we could do this. I'm racing. Gosh. This is not going well for me. I hope it's going better for y'all. Still felt slow, but it felt a lot faster than having to plug in a -3 and do it by hand. I got f of -3 equals -412. Do you have this column right here? Did you catch the 0? Why does there have to be a 0? Because there's no x term. There's no x term. We skip from x squared to the constant. Do y'all like this? I think it's awesome. I've used this in calculus so many times, where we just have to go in and evaluate some number, and we're like, oh, it's going to be forever. It's going to take me 10 years. But wait, synthetic division is a little faster. All right, let's go on to the next thing. Almost to the next thing. So that was called the remainder theorem, where the remainder is equal to f of that number. Okay? The next thing is called the factor theorem. The factor theorem. And so the factor theorem is another theorem that helps us analyze polynomial functions. It tells us how zeros of a polynomial are related to the factors. Okay? It tells us how the zeros are related to the factors. Let me ask you this. On the remainder theorem, if I got a remainder of 0, what would that tell me about the location of that number? Not at the origin, but on the x-axis, right? So if let's pretend, Gracie's always about, let's pretend you're the queen. Yes, Your Majesty, that's me, right? Let's pretend I got a remainder of 0 at the end, right? What that tells me is f of whatever number I used to find my synthetic division thing, f of whatever number is 0. That means that at location number, my y value is 0. Do you see how that plants me on the x-axis? So if your remainder is 0, what you're dealing with is a factor. Factors like this, where if we set them equal to 0 and solve, we can find our x-intercepts. Do y'all see how this is all coming back around? We're all working together here. Jaden says, I'm not seeing that. Here's the factor theorem. It says, according to the factor theorem, k is a 0 if and only if x minus k is a factor of f of x. You'll know it's a factor if there is no remainder. You want to write that down? You will know x minus k is a factor if there is no remainder. I always, when I get my last number, if it's a 0, I make it a smiley face. I think you've seen me do that several times. The reason I do that is because now I know, oh, that was a factor. This is on the x-axis. This is a 0. You will know x minus k is a factor if there is no remainder. Okay. Any questions on that? Okay, so here's at the very bottom, we have this problem. It says, using the factor theorem to find the zeros of the polynomial expression. So show that x plus 2 is a factor of x cubed minus 6x squared minus x plus 30. Show that it's a factor. Okay, I'm going to go on to the next page so I have more room to work here. We are showing that x plus 2 is a factor of x cubed minus 6x squared minus x plus 30. My question for you is how? How are we showing that? This is example 2, by the way. How are we showing that x plus 2 is a factor? So we're going to use synthetic division. And if it's a factor, what will my remainder be? 0. Okay? So we're going to use synthetic division. What goes in the box right here? Negative 2, not 2, because it's not x equals 2, it's x plus 2. And in my coefficient land, I got 1, negative 6, negative 1, and 30. Y'all trucking along? Better than my last class. Golly, they were so sleepy today. Well, if I could add correctly. What in the world? Here we are. Looky there. How do I know it's a factor? Okay. So the second part says, once you show that it is a factor, find the remaining factors. Find the other factors that exist here. So we know one of our factors is x plus 2. What's the other one? What did this quotient give us? Look right here. This piece is the quotient, right? That's the coefficients for the quotient. So what's the quotient? 1 x squared. So that's the other factor, isn't it? Now, can we break that down even further? Yeah. It could be factored, right? It's quadratic. What'd you got? Negative 3, negative 5. So one of our factors is x plus 2. We proved that already with the synthetic division. The other two factors are x minus 3 and x minus 5. Then it says, use the factors to determine the zeros of the polynomial. So where would my zeros be?
Negative 2, 3.
Perfect. X equals negative 2, x equals 3, x equals 5. So what does this thing look like graphically? Let's tie it all together, a real big pretty bow. This will tie in x 5.2, 3, 4, and 5. What does it do? It crosses the x-axis at negative 2. What else? 3 and... What's the multiplicity on all three of these? 1. So on all three, it's going to cross through, like a linear factor would. Okay. What are my tails? Down and because it's an odd positive. Odd positive. What's my y-intercept? 30? How do you know? Because if you plug in, f of 0 is 30. Y-intercept. I'm just going to count by tens here. 10, 20, 30. That'll work for me. Kind of got a visual? Not real sure where it crosses the, where it bottoms out over here. I would imagine it maxes out at 30, but I don't know that to be true. Without some calculus, I'm going to have a hard time guaranteeing anything. But we do know where it crosses. We can kind of get a pretty good shape figured out. What could I do to go figure out what is f of 4? I could plug 4 in. What else could I do? You could use synthetic division to figure out what's f of 4. Right? You could put a 4 in the box and go from there. Any questions on this lesson at all? Okay, you got 9 minutes, so we could do another try it or we could call it for today. It's up to you. Your homework's posted, okay? On tomorrow, Tuesday, in 7th period, we need to grade 5.4 part 1, 5.4 part 2, and your homework for tonight, 5.5. That will all get you ready for your test on what day? Thursday. Okay, so we're gearing up for that. Are y'all feeling better?